And welcome everybody to the Daily Space Weather. Looking at the sun here for the past approximately 35 hours to see at least one new sunspot growing there in the northern hemisphere. Besides that, things mostly stable. That's a composite series of images from the Solar Dynamics Observatory. That is 3 different species of ionized iron. It's 335, 193, and 94 angstroms. We're bringing you the Daily Space Weather Show, where we bring you what's going on from the surface of the sun all the way down to the lower 48. It's what we do here at the Smash News Network, least busted name in news. Here's 171 angstroms as well. It is the house favorite wavelength. And there's a little closer look at the equatorial portion of the closest star. By the way, if you enjoy the content, don't forget to press the like button. Yeah, help us out with the algorithms, as they are, shall we say, silly. We are bringing you the most comprehensive daily space weather content in the known universe, as well as the most detailed imagery you'll find of the closest star. We realized that there was a niche in the daily space weather content, so we decided to fill that void back in, well, about 2016. 2016, 2017, I don't know. We're pushing 7 years of doing daily space weather content now. So press the like button. If you're new to the channel, do yourself a favor and press the subscribe button. And regardless of all of that, congratulations on realizing that the channel exists. Cheers. Thanks to our new subscribers over on YouTube as well. Don't forget to leave us a comment, whether nice or mean. It's not going to hurt my feelings. Or maybe it will hurt my feelings. I don't know. Try. By all means, try. Especially if these videos are making you triggered. So, again, thanks to our new YouTube subscribers. In all seriousness, today's featured product is the Croissant Earth Society. Have you joined the Croissant Earth Society yet? Or are you still believing NASA's lies that Earth is an oblate spheroid? Why do you believe NASA? I mean, geez, NASA totally has incentive to convince you that the Earth is spherical. I mean, come to grips with reality, folks. Earth is shaped like the French breakfast pastry. Not like an oblate spheroid. What are you, crazy? You believe NASA's lies? It was founded by Nazis. What is wrong with you? So stop believing NASA's lies. Come to grips with reality. Join the Croissant Earth Society. That's today's product that is linked below this video in the description section at our Redbubble shop. When will you stop believing NASA's lies and join the Croissant Earth Society? Please also visit our affiliate links. One of those would be the Hemp Lucid link. If you're shopping for CBDs, mushroom gummies, stress immune or sleep stacks, you save $15 on those. Oh, also check it out, the mushroom gummies there as well. Saving $5 on those. So now in the blueberry lemon flavor. I don't even think I've tried that one yet. So multiple items there on sale at the moment. There you go. Save $15 on the capsules there, the sleep, immune, and stress stacks, or save even more by getting the full stack. So that's one of our paid affiliate / sponsor links. Help keep this channel existent, publicly visible, and free for all to view by purchasing your Hemp Lucid products through our link. You'll find the link below the video and on the homepage at smashomash.com. Today's featured product from the Amazon shop, and it's Amazon.com/shop/smashomash is our air fryer. So this is in plum purple, and our kitchen would not be complete without an air fryer. So this is a true revolution in kitchen cooking. If you don't have an air fryer, try one out. This small go-wise design is under $60 here from our Amazon shop. Again, it's amazon.com/shop/smashomash. Many items in there that are invaluable in our kitchen. And if you want to support the channel via subscription services, become a member of the Smash team. There's a gold level. There's a gold annual paid up level. There's a silver level. There's also a bronze level, which costs $0 per month. Get email alerts about videos just like this one by becoming a member of the Smash team. You see, in 2018, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security social media stockade of the internet underground, where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash team. No, you certainly can hire the Smash team. I'm sure you can go to a website. Indeed, you are watching this video. So, yeah, smashomash.com/Smash team. And let's get back to some solar activity here. Here's the SDO continuum. Once again, that's the past approximately 35 hours, and at least one new sunspot did indeed form up here in the northern hemisphere. Besides that, mostly stable, a little bit of evolution of this active group. It has been a little less active in the past 24 hours. And here is the SDO magnetogram. So it looks like we may have a small uptick in the sunspot number here. With that one new group, we'll show you high-res imagery of that later in the video before we do our meteorology segment. And let's see what's been erupting. Great image there of Kluchevskoy on the Kamchatka Peninsula. So these are the volcanoes that have been erupting over the past 24 hours. Kluchevskoy there, producing an effusive and explosive eruption. No indication on the ash plume there. However, 4,000 meters from the summit, that lava has been descending. Semeru also continued uptick there on East Java, Indonesia. It's producing a 17,000-foot ash plume, flight level 170. Flight level 070 over Dacono on Halmahera as it explodes. Popocatépetl exploding, now moving to North America in central Mexico. Popocatépetl producing a 20,000-foot ash plume. Sporadic emissions from Fuego in Guatemala. Effusive explosive eruption from Sangay, producing a flight level 200, 20,000-foot ash plume over Ecuador from Sangay, 14,500-foot ash plume over Ecuador from Revenador, 26,000-foot ash plume over Sabancaya located in Peru, as Sabancaya explodes, producing a flight level 260, flight level 210 over Ubinas in that same nation, as Ubinas explodes. And Villarrica continues with elevated activity as well. Please do not pole vault the caldera. Next, we'll go over earthquakes. We'll cite quakes of a 5 or greater magnitude for the past 24. There are the past 90 days, and here come the past 24 hours. So it looks like no major large earthquakes over the past 24. Some right on the west coast of North America, however, like this 4.7 off the coast of Oregon. The first 5 or greater magnitude on the list is a 5.1 at the South Sandwich Islands. That was at 2:06 this morning. So yesterday, very calm day as far as earthquakes. Next, the Bonin Islands there, south of Japan. That was a 5.1 at 2:33 this morning. Then a 5.0 in the Banda Sea. That was at 6:28 this morning. And finally a 5.1 at Indonesia at 8:58 this morning. Those are the quakes of a 5 or greater magnitude. And now we'll return to space. So looking at the 304 angstroms wavelength, we can see a very large number of plasma filaments suspended by magnetic fields, defying gravity, and really greatly increasing the probability of coronal mass ejections. There's a lot of plasma pointed at the Earth right now, and I mean, you can see some of it, some thick rope-like structures there. So that's the 304 angstroms wavelength. It is ionized helium, and you see many dark absorption features there. Those are the plasma filaments that I was talking about. So, now getting into some more stats here. The 10.7 centimeter radio flux is now at 161 solar flux units, 161 is the current radio flux. It comes from the upper chromosphere and lower corona, about where my pointer is. The transition region between the solar surface and the sun's atmosphere. Here's the 1 year graph of it to put it in context for you. The black line is the radio flux. The red line is the sunspot number. Space Weather Enthusiast dashboard forecasting geomagnetic unrest conditions to start at any moment and last through about ending before midday tomorrow. It's from a coronal hole high-speed stream, and we don't see any of that indication yet. At least when I did show prep, I didn't. So expect geomagnetic unrest in the coming 24 hours or so. So again, that's from a coronal hole high-speed stream. And let's move on to take a look at Earth's magnetic moment from space for the past 4 hours. It is geomagnetically calm. This depicts magnetohydrodynamic pressure to about 12 Earth diameters. It's the Geospace Magnetosphere movie. It shows magnetohydrodynamic pressure in nanopascals, which are the units of magnetohydrodynamics. Pretty homogeneous plasma pressure around Earth. Next, Earth's magnetic moment from the ground level. Also the last 4 hours. And also geomagnetically calm conditions, depicting magnetic flux density here. No major variations going on there in Earth's B field. Planetary K-index only at 1. Again, we are expecting geomagnetic unrest conditions. There could be some chances of seeing the aurora tonight, depending on the strength of that coronal hole high-speed stream. They are fairly predictable, and let's move on to the solar wind data. Current conditions are quite unremarkable here. About 4 protons per cubic centimeter for the solar wind density. Solar wind velocity here about 360 kilometers per second. GOES magnetometers here are in a normal operating range. No big spikes in the GOES magnetometers. Now, Earth has recently moved into a South Pole current sheet. There's a sector boundary crossing. It looks like it's just occurred. Looks like it's just occurring now, actually. It was a bit delayed there, taking a little bit longer to leave the North Pole current sheet than we expected. Keep in mind the data here is 1 hour and 29 minutes old when we produced this video, so indeed Earth may already be in a South Pole current sheet. It's definitely happening sometime soon. And let's take a look at the sun's fields here from the line of sight perspective. Solar B field here depicted in blue, north and south polar fields in green and red respectively. Photosphere magnetism, the gong magnetogram there in grayscale. So there's our line of sight plot, which brings us to a very important feature, coronal holes. Again, this is what we're expecting a high-speed wind from. It's from this coronal hole right here, this what we call a transequatorial coronal hole. Those are the most geo-effective type of coronal holes. We do have some South Pole-oriented ones here rotating in the east. Let's take a look at those from the SDO, 211 angstroms wavelength, another about 35-hour video here from the Solar Dynamics Observatory. So these are North Pole. Whoops, these are North Pole, and these are South Pole coronal holes. And it looks like we do have another one that's transequatorial here, so we can expect an uptick in solar wind from that in about 4 to 5 days. Sweet. That brings us to sunspots. And check it out, the sunspot number here now back to 170 or so, maybe 169 there, according to the Royal Observatory of Belgium. Here's our sunspot and flare monitoring session. The major players for flares, according to this, would be this group here, 3452, and this group here, 3450. So 2 quite significant sunspot groups there on the Earth-facing portion of the solar disk. And here let's take a look at 335 angstroms for once from the SDO. And let's switch to the, what is this? The SDO magnetogram is next, I believe. There's the magnetogram. And we'll zoom in to show that a little closer for you. So only one significant spot seeing sunspot growth here. No real major sunspot decay. So one new sunspot formed up here. It might have already evaporated again, too. A little bit of migration happening down here, just north of central disk. So that was magnetogram. Here's the SDO continuum. And that is what about 100... Excuse me, that's what about 170 sunspots looks like. So actually there is another new sunspot up here in the northeast. So that, if both of these count, that'll be another 18 sunspots added to the list. Although we will lose some from this setting group in the southwestern limb. So that brings us to solar energetic particles and solar flares. I don't think we've had any spikes in the ghost proton flux. Indeed not. So now there is an increased possibility of spikes in the ghost proton flux here as the coronal hole high-speed stream arrives. That does create the sort of environment where we would expect to see spikes in the proton flux. So look for the possibility of that to spike up here in the coming days as well, especially if we see some large flares. As far as the flare profile goes, there is one flare going on right now as we produce the video. And that flare is from this southern sunspot. So let's take a look at the SDO. Here's 94 angstroms. That is some sweet imagery there, folks. And this latest flare is from this group down here in the southern hemisphere, moving right toward the center solar longitude. So again, multiple large solar flare players there. Let's take a moment to see what's going on overhead, Lehigh Valley, Pennsylvania. But before we do that, how about the 131 angstroms? There's another approximately 35-hour video from the Solar Dynamics Observatory. And how about if we zoom out and show the full disk? There you go. There are the timestamps and the full disk view. Next, we'll take a look at what's going on overhead. This is what's happening over Lehigh Valley, Pennsylvania. And you've got the Moon and Jupiter quite close together here at the moment. So you might see that if you're looking at the pre-dawn skies. You'll also see Venus high in the sky there if you're viewing the sky before sunrise. And if you have low light pollution and a low horizon and clear skies, you might even see Mercury there rising ahead of the sun. If you're viewing the dusk skies, you might see Mars chasing the sun there across the ecliptic. Next, your solar system forecast. Here's where things are today. We'll advance this 1 week to October 9th. We will have a crescent waning moon by October 9th. And let's take a look at the astronomy photo of the day next. The astronomy photo of the day is activity in the mesosphere. Yeah. The layer of the atmosphere below the thermosphere and above the stratosphere. It's the mesosphere. This kind of lightning occurs at about 80 kilometers, and it's believed to begin with a cloud-to-ground strike, followed by a rapid ground-to-cloud strike. Those red sprites are very fleeting and difficult to capture on camera. That is only one frame. The frame right before this and the frame right after this feature none of this activity. Red sprites, the astronomy photo of the day. apod.nasa.gov if you want to check them out yourself. Great high-res imagery there of those red sprites. As we zoom in closer and closer to Earth's weather. Moving right along to coronagraphs. Here are yesterday's coronagraphs, and we do see some minor CME activity, coronal mass ejections. We'll have to check and see if those are earthly directed here, which we will do during this video. So at least two there happening yesterday, one out of the northeast and one out of the southwest. 62 frames from yesterday. And here are an additional 28 frames from today. Only minor outflows happening there today so far. A little bit of a coronal mass ejection happening there. It's looking pretty minor. Let's take a look at LASCO C2 and C3. And let's get a little more detail here. All right, so yesterday around 1800, we see a CME. First of all, around midday, we see a CME out of the southwestern limb. And then later in the day, around 1800, we see one out of the northeastern limb. They're both minor. And let's see if we can figure out if those are earthly directed. So midday and about 1800. We'll also look at stereo A. Feel free to pause the video on this frame if you're not familiar with its location. It is still close to the Earth, but gaining distance, which will help us to calculate the trajectory and velocity of coronal mass ejections. So let's bring the raw coronagraph back. There's midday. Little CME out of the northeast and one out of the southwest. A little missing data there as well, not exactly helpful. And let's see the difference imagery. And let's cut to our custom coronagraphs. Once again, unfortunately, HelioView are not uploading the SDO data, so we've only got the SOHO LASCO C2 and C3 there. And those are those minor CMEs. Let's zoom in one step here. And then we're going to take a look at 193 angstroms. So here's 193 angstroms from SDO. And we're going to bring this back into yesterday around midday. That's another far side coronal mass ejection, I suspect. And then later in the day, hey, that one likely has an Earth-directed component. So right in here, yeah, nice. So that's an Earth-directed CME, folks. Right from, watch this area right here. Can zoom in a little bit on that. So there's that CME. That does likely have a minor earthly directed component. We can expect that to arrive late in the day on, I'll say early in the day on October 4th, actually. Late in the day, October 4th. Minor CME impact expected. Don't expect to see anything beyond a KP 5 to 6 from that. Just a mild geomagnetic storm likely from that minor CME. So there you go, some additional space weather on the way. Pretty sweet. And what's next? Filaments are next. And man, oh man, there are certainly a lot of filaments. So there's the El Teide, Spain ground-based observatory. And look at the number of filaments there. I mean, a solid dozen filaments. Let's actually show the grayscale here so it shows prominences as well. So check that out. And we'll bring up the last image here to do a quick count. So we'll call this 1, 2, 3, 4. And 5, 6, 7, 8, 9, 10, 11, 12. At least a dozen filaments on the Earth-facing portion of the solar disk. Some of those are really huge. We have named this one right here. That is the Pierre-Marie Robitaille filament, after the author of the Liquid Metallic Hydrogen as a Solar Building Block publication. If you haven't read that, check it out. Massive number of filaments on the Earth-facing portion of the solar disk, and several of those could use names. So if you want to name them, come join us over on Twitter. Yeah, Twitter, or the platform formerly known as Twitter. Join us over there. Thanks to our new followers over on Twitter. One of these days we'll even reach 500. We've only been there since 2019 with over 22,000 tweets. Yeah, 22,000 tweets. Anyway, here are the past couple of hours from the GOES 16 SUVI. Again, that latest flare did come from this sunspot in the southern hemisphere. And we'll zoom out to show the time and date stamps. Looks like some plasma instability happening over here in the southeastern limb as well. So plenty of stuff going on despite not that many flares happening in the past couple of days. Again, there is significant flare potential, and let's blast through our bonus features segments. Satellite charging hazards are minor. Some surface charging hazards here in the eastern Pacific. Those are of low energy electron type on the outside of spacecraft. They won't cause any damage. They'll just cause some minor communications failures, possibly. Surface charging hazards there in the eastern Pacific. GOES electron flux here in an operating range. Nothing to write home about there. Expect to see this crater when the coronal hole high-speed stream shows up. At the moment, doesn't look like it's shown up yet. Here's the one-year graph to contextualize the electron flux. That is the past year reported by Solon.info. Here's the forecast model. NOAA expecting flat levels. I would expect lower levels than that if indeed there is a coronal hole high-speed stream impact. We would expect this to be down here, not where they have that green box. We'll also show the layer where it's measured, which is the F layer of the ionosphere. Feel free to pause the video on this frame if you're not familiar with atmospheric temperatures, electromagnetic radiation penetration, and chemical concentrations. Here's the vibrational frequency of the bridge between Earth and space, the F layer. That's about 300 kilometers of altitude. And things are looking very normal. We apologize if you were hoping for an apocalypse, but no apocalypse is forecasted by any of this data. Everything looks perfectly fine. Space, not very scary. Make sure you watch yesterday's daily space weather video for refutations of a lot of doomsday nonsense cult crap. Here's the anomalygram in the ionosphere. And if we do see geomagnetic unrest, you can expect to see more red on this tomorrow because the ionosphere will be scintillated by the incoming solar plasma. Anyway, there's the current situation, anomaly in megahertz from a 30-day median. Ionosphere looking just fine. There's the latest image, 12 o'clock Universal Time ionogram and anomalygram. Here's your ionosphere nowcast. It shows you the maximum usable frequency, the total electron content, and the anomalies in both of those. The Ionosphere Nowcast. We've just recently picked this up. Let us know in the comments if you like that, if you think we should get rid of it. Although signs point to us keeping it, because this is a space weather and earth weather dictatorship. Seriously, though, we take all comments into consideration. We read all comments even if we are unable to respond to all of them. We also show the total electron content by itself. It's free electrons from about 12,500 miles of altitude down to ground level. That's about where your GPS satellite is located. Here are the most likely places to see errors in your GPS. Things remain quite organized. It's about where you'd expect the total electron contents to be. We also like to show the anomaly in the total electron content from the 10-day average, and we are seeing some significant anomalies here over North America. Also Central America. So check that out. Some significant electron content signals there over the western U.S., the eastern Pacific, Mexico. I'll play that through one more time before we show you the high-res images of the closest star to see if indeed those new sunspots remain intact. So there is the latest and the latest. So this group up here, there's actually like two new groups up there. I'm not sure if those will get names or not. This group up here, that's already beta class at least. It's beta gamma class. Anyway, the biggest flare players would be this one here. Beta gamma delta class. And this one down here. Also beta gamma delta class. So that has been the biggest flare player here. Again, it just produced a flare while we created the video. I think it was only a C-class event. Let's check. And indeed, that was only a small uptick there in the X-ray flux. It was a C3 class solar flare. And that brings us to our meteorology segment. Before we do that, let's just briefly cut back to the high-res images here. There's the SDO intensitygram and colorized magnetogram. Looks like an active region forming down here at a very high latitude there in the southern hemisphere. Possibly a sunspot forming down there. And this is the Smash News Network, least busted name in news. Here comes meteorology, folks. And we're starting things out with some wave chasing. The world's largest waves at the moment here are in the western Pacific, northeast of Philippines. Pushing 35-foot waves up there, close to 35-footers. There are also some stormy seas down here in the Southern Ocean here, south of Africa. Those are actually pretty close to the same size as those typhoon-generated waves northeast of Philippines. So a couple spots with stormy seas there. Those are by far the stormiest seas. Let's take a look at air masses. Here are the surface winds of this side of the planet. Strong winds there. Certainly hurricane force and beyond northeast of the Philippines. Here are the jet streams of the eastern world. Shout out to our viewers from this side of the planet. Jet stream blowing backwards here over the western Pacific. Jet streams of the central world depicted here. Surface winds. Shout out to our viewers from Europe, Africa, and the Middle East. Finally, shout out to our viewers from the Americas, the Western world. There are the surface winds for y'all. And here are the jet streams. Jet stream injecting cold air all the way down to San Diego right now. It's a cold morning in San Diego indeed. Next, our pressure map. That's the mean sea level pressure there from windy.com. They've got a great mobile app. You may want to download it. It's pretty sweet. Windy.com. That's what's going on with sea level air pressure, barometric pressure, if you will. And let's take a look at clouds and fog over the Americas. Look at all the low clouds there over the eastern Pacific. Low clouds continuing over the eastern Pacific for an extended period. Clouds and fog. It's too dark over half the country to use the visible satellite, so we use the shortwave radiation, part of the infrared spectrum. Next, your weather.gov map, and it looks like a foggy day in North Dakota. Dense fog advisory up there. If your location is lit, click your location on the map at weather.gov. Those are more counties than we are willing to cover. And here come some forecasts. So we like to show the GFS 72-hour forecast. Why? Because it tends to be accurate. Yeah, accurate. That's what we're into. Facts. So some heavy weather here coming to Oklahoma and Arkansas in the coming 3 days. Also Texas. So a band of strong storms are expected to develop there in about 3 days. About 2.5 days, I should say. That's the GFS 72-hour pressure and precipitation forecast. Some snow falling in the Rockies. Speaking of snow, here is the total accumulated snow depth positive change in inches. So a bit of additional snow here to fall first thing in the month of October. 72-hour total accumulated snow forecast there in inches. We'll also show temperature anomaly. That is in degrees Celsius for the 72-hour GFS model. Warm temperatures in the eastern portion of the country, mostly cold temperatures in the western portion. And last but not least, the jet stream forecast, the 72-hour GFS 250 millibar wind forecast. And that huge bend in the jet stream there will continue. It will move a little bit to the north here. So some huge pressure gradients being created there by the jet stream injecting cold Canadian air into the U.S. What else you got, you ask? Well, we've got lightning. There's what's been going on the past about 10 hours. And let's check a real-time lightning map. Here's the global lightning map from lightningmaps.org. Next time you hear thunder, highly recommend you check it out. Powered by blitzachtung.org, the German lightning website, as the sun rises over the Mississippi Valley. We'll close things out with Doppler radar, U.S. clouds and fog and water vapor. But first, take a moment to press the like button. Press the share button as well. What about comment? How about, press all the things. Click all the things. And don't forget to visit our homepage. To help support the channel, keep the videos existent, publicly visible, and free for all to view, smashomash.com. We launched that in 2019 in response to the pathetic, ridiculous, putrid, evil, and corporatist censorship on the internet. Smashomash.com, we needed our own websites, so we created a massive web ring for people just like you. Become a member of the Smash team, visit the affiliate links, and so on. Thanks to everybody who has. Thanks especially to the Smash team, especially Gold and Silver Smash team level members, for increasing the probability these videos will continue to exist. Smashomash.com, and welcome to the Neo-Renaissance. Here come the final segments of this video. U.S. Doppler radar, which depicts vertical motion in the air column from ground-based Doppler systems. Here is clouds and fog, space-based systems depicting 3.9 micrometer infrared radiation. It shows clouds and fog even at nighttime, and here is water vapor. We've got overlapping systems here, so we've got two different altitudes happening here. We've got dry air at the ground level, and you can see moist air moving over top of it. And that's creating these scattered precipitations here around the southern Rockies. And you can see those here on the Doppler radar map. Scattered showers and indeed snow showers in the higher mountains there. This is the recap. U.S. Doppler radar, clouds and fog. And there is water vapor. Hopefully that cleared things up. Hopefully you aren't spooked of space. Hopefully you can forecast your Earth weather and space weather as we empower our viewers to do so, filling your heads with facts instead of propaganda and nonsense. Anyway, we'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smashomash, signing off. And may that solar wind be at your back.